Hello, welcome on webinar using FARO 3D scanners to capture and analyze crash and crime scenes. So my name is Andrej Orešnik. I come from IB-CADDY company. We're located in Ljubljana in Slovenia. With me is also a respected partner FARO. There is Peter Schuh, who is distributor manager for Central and Eastern Europe, and also Daniel Previtt, who is actually application engineer in field of public safety and forensic. I will make a short presentation of our IB-CADDY company. Actually, we have three locations. One is Ljubljana, the second one is Kamnik, also in Slovenia, and the third location is in Belgrade, the capital of Serbia. Actually, we are working from 1991 in a different field of, let's say, industry with a different solution, software, also hardware solution. But today we will talk more or less about FARO solution in segment of public safety and forensic. So actually, with FARO, we are working quite long time, and we are actually the official resellers for all FARO products in 3D manufacturing, let's say metrology, 3D design, reverse engineering, construction, BIM modeling, and so on, and also public safety forensic, what we will present today. So I will pass my words to Peter Schuh. Peter, so please, if you can present your part. Thank you.
Thank you, Andrej. As already introduced by Andrej Orešnik, my name is Peter Schuh, and my role at FARO is distribution manager for Central and Eastern Europe. So it's a great pleasure for me to welcome you in the name of FARO to our today's webinar, and thank you for joining us today. Before we get started, many thanks also to the whole team of our great distribution partner IB-CADDY for arranging. Today's web session will define FARO in the field of public safety and forensics. And we will give you a picture how our FARO solutions interact and optimize the use of reality data, and how FARO solutions can help you in your daily practice. So let me start with some general informations about FARO. Who is FARO? FARO is the world's most trusted source for 3D measurement, imaging, and realization technologies. And what drives us at FARO? To enable an easy and accurate connection between the physical and the virtual world. Brought down to the point, FARO is a global developer, producer, and provider of 3D measurement, imaging, and realization technologies. Our headquarters are based in Lake Mary, USA, Korntal, München, and Germany, and in Singapore. FARO provides specific measurement and 3D laser scanning solutions, mainly for the following industry segments: product design, manufacturing, architecture, engineering, and construction. But in our today's webinar, our focus is on FARO's 3D laser scanning solutions for the segment public safety and forensics. FARO provides hardware and software for a seamless connection between real objects and their digital representations in both directions. How does this work? Let's take a look on FARO's main product range for the segment public safety and forensics. On the hardware side, we have a complete range of 3D laser scanners, combined, and also, of course, 2D and 3D handheld scanners. And this hardware is combined with a wide range of software from solutions for 3D point cloud processing, registration, and documentation, up to FAR visualization and 3D reality data sharing. The next thing we'll see is that FARO also provides some specific solutions. As example, for mobile mapping, 3D scanning, drone scanning, and also mobile scanning. As we can see at those pictures, the core of all these specific solutions is always a FARO 3D laser scanner. Let me close the general information about FARO with a very important point. We saw in the slides before the product line of FARO in the field of 3D laser scanning. And you can believe me, it's a great one. But most important is that FARO provides over the whole usage time of our equipment a worldwide excellent technical service, as well support and trainings to use FARO devices in the best possible way. Yes, I really hope I could catch your interest for the following practical session. And for this, I hand over to my colleague, our field application engineer, Daniel Brevitt. Thanks for your attention. David, the stage is yours.
Thank you very much. Let me just share my screen. Hopefully that's swapped over okay and everyone can see my screen again. So yes, my name's Daniel Pruitt. I get the really fun job today because I get to show you all the exciting and interesting things that, you know, adopting these solutions can actually do for you in, you know, a public safety capability. So a little bit about me then. I'm an ex-military policeman. I was a soldier, then military police. I'm crime scene investigator trained, and I became a specialist in digital multimedia evidence. So that was all digital evidence. From then, I then became an expert and the lead in the UK Tri-Service in virtual crime scene reconstructions. So that was using very old traditional methods of 3D modeling and animating, all sorts of different things. And that's when we adopted laser scanning, all of course until FARO gave me an opportunity to get out of the military. So that's just me then, and that's my background and why, you know, I am involved with public safety with regards to FARO. So today then, I'm going to show you some of the exciting capabilities. However, the main concept and the main idea of it is to record scenes or record areas, and this could be in security or crash or crime. We have to record these areas and fully document them in 3D. And there are some huge advantages for doing this. They may seem quite obvious, but there are some things I think people take for granted, and it's little things like if you can record an entire scene, you're going to get things that people miss. And you know, we are all human, we do make mistakes, but not only that, we miss things because sometimes evidence isn't valid or recognized at the time. If you can fully document that area, so you can re-look at it again at a later date, years down the line, it's just worth its weight. It's just so valuable. Not only that, it does things like removing the human bias from the equation. When you use a camera at a scene, you as an investigator, it's down to you to depict what's important. And you're making these conscious biased decisions that this is important and this is important, which is fair enough. You're a trained investigator. But it's also quite valuable to be able to take that human bias away and just record everything, which is what you can do with these laser scanners. Another thing I really like then is the ability to capture evidence in situ. Hopefully that translates well. I know got lots of different countries in here today. For me, evidence in situ is in evidence in its resting place. As soon as you disrupt and move evidence, you'll be aware you're damaging evidence. It's destructive when we recover things. The ability to laser scan, for example, I laser scanned something under a bed. If you take a picture of that item under the bed where you can see it, you only get a very small amount of context. However, if you laser scan it from every side and then in the software remove the bed, you have your full 3D representation of that piece of evidence without it ever being touched and disturbed. That's the power of laser scanning and evidence in situ, and that's one of my favorite things about it. From these laser scans, then we can create videos, and I'm sure you all already agree that a video can be so powerful in an investigation. Not just in court, but we can use video in interviews. I've had some really good successful stories, including videos into interview after cautions. Just showing somebody a video instead of showing them the crime scene report or trying to explain to them a ballistics report, just putting it all and collating it together into a video just speaks thousands of words, and it can get the point across very quickly and easily, especially to a courtroom with a lot of people. I must say this isn't a real example, it's all dummy and everything. You can see here we've included things like bullet trajectories and blood pattern analysis. That's a lot of reports and a lot of information going on, but it's all been put into one simple video for you to see. So that was done with the Focus laser scanner, which is our main laser scanner, and Scene, one software application. Here then is a quick example of what the handheld scanner can achieve. This is the Freestyle 2, and again, this isn't a real scenario, this is a mock example. And you can see here the level of detail you can get from a handheld laser scanner. Really nice thing with a handheld then is you can get in all the gaps and fill in all the data without using lots of different positions. So it's a really nice tool that works hand in hand with the Focus scanner, the big one. It's almost like a big paintbrush and a little paintbrush, just to fully build your scene and recover as much data as possible. That was always my intention. It never used to take up too much time when I was on a scene, because I'd leave it running whilst I was doing other things. I've got plenty of other jobs to be getting on with, and it would just run in the background, and I would document everything I possibly could. And it's amazing how it can become valuable at a later date. Very quickly then, I just want to bring up hashing of data. I'm sure a lot of you will already be aware of what hashing is if you're working with digital evidence much. But in case you're not, what hashing is then is the application of a digital signature to a data file, and it can be anything. It could be, you know, a photograph, a video, or in this case a laser scan. You can apply this hash value to a piece of data, and it is given a signature, just a very long code of numbers. If somebody was to change that file at any point, and it could be anything, I could change a single pixel on a very high resolution photograph, and the hash value would then change completely, and it would no longer have the same signature. So the reason why I bring this up then is because we're going into like an age of where all digital evidence needs to be hashed, because everybody has this capability of editing things. Everyone can edit photographs on their phones, and they can edit video on their phones. That's just on their phones, let alone if somebody really knows what they're doing. So hashing is extremely valuable. I actually used to hash all of my evidence personally. So if I say enhance the piece of CCTV, I'd hash it. So then later, if I get called to court and my evidence is in question, the first thing I do is actually check the hash value to see if it's even my piece of evidence. Because for all I know, once it's left my office, somebody else could have edited it or changed it, tried to enhance it further. I want to be sure that that's even my piece of evidence before I even start looking at it. And hashing used to do that for me. The reason I bring this up then is because our laser scans now hash at the point of source. This is just insanely valuable because in theory, you could hash any laser scan data, but that means taking it from the laser scanner, putting it onto a computer and then hashing it. So you have this period, this area of where that data could be questioned from when it's been taken away from the scene, removed from the scanner, taken into a lab, put onto a computer, and then hashed. There's this huge area of where, where you could question what's happened to it. So as you can see on the screen here then, hopefully you can see that, this is an example of how our digital signatures are applied at the point of recording. It's the earliest possible point. As soon as that laser scan is recorded, the hash value is assigned. And then later down the line, if you are questioned in court, which you could be, saying, this looks like a digital evidence, how can you say this is real? Well, you can load up the raw scan and cross-reference the hash file and say, this is the raw scan that was recorded at that scene at that time. It cannot be questioned. It really can't. It's completely like proof. It's amazing. Our laser scanners are the only laser scanners that can hash at the point of source. Any other device is going to have to go back to the lab and then again have that area of where it could be questioned. Now, I kept that quite brief. I've done a whole hour webinar on hashing. If anybody's interested in it, I can get that to you. I'll have a copy of it, or we can have another meeting another time and I'll talk you through some more hashing examples. However, I want to show you some other interesting stuff we can do then with our scanners and our software. So we have this a package called Scene2Go. It's great for us in public safety because there is a similar package that FARO do called Web Share Cloud, and it's a way of viewing your laser scan data without needing the software. So you can basically share it with other people. Only problem is we don't want evidence on the web, not most time anyway. So we've tried to keep it offline. This is where Scene2Go comes in. We can create an executable file, very small package that will fit onto a forensically sound device, a worm. So something like a CDR or a DVD-R. Forensically sound because it can't be rewritten. You can fit this Scene2Go file on one of them and distribute it to who you need, so then they can view the evidence. Not only that, then you can collate evidence within it. Now I've got an example here. I'll just load it up. This is a Scene2Go example. Now this was a real scene. However, for the sake of this, the main area has actually been blurred. As an example then, so this is called Scene2Go. And again, I would not need to install anything to run this. As long as I have a 64-bit machine or a Mac, this will work, no problems at all. Now I can navigate around my scene using 360 photography, or I can load up actual point cloud data. Now, because that point cloud data there, that's the actual laser scan data is there, even if I'm looking at the photography, that point cloud data is still hidden behind. So if I really want to, I can still take measurements from a photograph, which is quite an unusual thing to be able to do, and it's really valuable. This won't save because again, this will be on a write once, read many device. However, this means you could distribute this package to people and then they could go through and re-examining and looking at things. Another really nice touch with this then is you can embed files. So if you have other evidence, videos, photography, reports, audio files, anything, you can embed that file into the package and then place it into the scene. So here, as an example, then I've got a ballistics report that was made in another one of our softwares called FARO Zone. And I'll show you that a little bit later. But just as an example of how you can embed data then, if I click that link, it will open it up. This is really nice for, I find, crime scene images, because so often we see crime scene images and they're just in a kind of disk, and there's just like 100 odd crime scene images, and you're just looking through them all and they don't have any context. if you can place that crime scene image back on the wall where it was recovered and where it was located, all of a sudden it has a lot more context. You can just click on it, open it, and it's all together. All your evidence is on one thing, one piece of evidence, rather than having lots of different discs, you know, the videos and the images and everything. It's a really nice collation tool. I will just close that down. Okay, another thing I want to show you then is the possibilities of using things like CCTV or any imagery really with laser scan data. This is one of my favorite things because I work with CCTV a lot, and I realized the struggle of how difficult it is to try and take things like measurements from CCTV. It's extremely hard. So here then, I've got a little example. What you're seeing now then is FARO Scene. This is our primary software. This is what you'd need to build the laser scans. But there's still a lot you can do in it. You can create videos, you can create that scene to go file you just saw. You can also run images through it, like from CCTV. So here for an example then on the left of the screen is just an image. That is just a picture. Mock CCTV, I don't really have a CCTV camera here. It's just a quick picture taken. However, what I can do is I can take that image and embed it into laser scan data. So here I laser scanned that area, just a couple of scans, nothing too much. It was no more than a few minutes of scanning. However, if I locate the image, you can see what I've done here. I have placed the image and aligned it to the 3D data. Not only that, I've created a foot point of where that person's foot meets laser scan data. So you should see on the screen there, appreciate it might be a little bit difficult over Zoom. There is a point in which my foot is placed on the floor. Now, because that picture is now aligned, you can now take a vertical value. So that is how I've managed to recover the height from a still image. Now, other things need to be taken into equation, like the CCTV image has to be treated correctly. It needs to be recovered and straightened up. Any sort of wide angle or like fisheye lens, it needs to be treated and straightened out. However, you can see the power of CCTV really in laser scan data and what you might be able to do with it. Now, considering I'm quite hunched over there, and you know, it's always rough taking heights from CCTV because people are walking, you don't know what their gait is. That's actually pretty close, and that's about 4 centimeters out. I'm a little bit taller than that, but I am hunched over. What also is really interesting then is you get an almost perfect point at which the image was taken. I haven't placed that camera there. That has been calculated from aligning the image to the laser scan data. So that of where the camera was recorded from has been calculated by the software, which is really interesting actually, because people are starting to recognize that actually this could be used to place people back into a scene when an image was recovered, which is quite a nice concept. Still on CCTV then, I've got an example here of how I took it a little bit further. So here is some video footage of a car driving past. It's not going particularly fast. Now, again, it needs to be done correctly. It needs to be done using like video forensics tools. So unfortunately, I had that capability. So all I've done is recovered 2 frames from the video footage. You can see here, frame 1, frame 1900, and then frame 1959. What that means is I now have a perfect timing, providing I read the data correctly, because I know the frame rate, or I can read the variable frame rate of that video footage. I have a perfect timing between these 2 frames. So if I wanted to determine the speed of this vehicle, I now need to figure out the distance. And I can figure out the distance again by going out, putting the laser scanner down a couple of times, and then layering those images into 3D space. Again, I create a point on a what we call it as a plane in 3D space on the ground. And when I align the image, I get the base point of the tire. And you can see here, once the image is placed vertically, there's me just coloring the scan, and then I place the image vertically to fit it. And I did 2 measurements to make sure, you know, I'm getting pretty close. But the main measurement I took was one from the base of the wheel. And you can see here that it's probably very hard to tell in the video, but the car's actually coming across the road because it was actually overtaking down there. However, now I have a distance. So now I've got I'm not going to do the maths. I'm no good at maths, but I got the timing and I got the distance. That means I can now figure out the speed of that vehicle over that area. Obviously, with speeds, it gets complicated. There's other things to take into account, like was it slowing down, speeding up, and stuff. Okay, then I have to be conscious of time. Again, I could talk about all of these different things for a lot longer, but I only have so much time with you to show you lots of different things. So I want to show you blood pattern analysis next. Now, I'm sure some people in here have done some blood pattern analysis before. What I'm going to do is just close this software down because I actually want to show you this in the software. I think it's just nicer to actually view it in person almost, rather than me just showing you a video. So what I have here on the screen, when I load this, is a picture and a point cloud. And this is in our secondary software now. This is called FARO Zone. Now, we use this software after building up our laser scan and then we use this software for public safety. So it can do all sorts. So it's got blood pattern analysis tools, bullet trajectory, animation, drawing tools. There's a lot. I just want to show you some of the main features of it to give you an idea. So this is one of my favorites. This is the blood pattern analysis tool. Now, what you can see then is a laser scan. It's just a small section of a laser scan, and then a photograph. This photograph then, it's not the best example because actually it's not a very square image. Ideally, you know, crime scene images, they're usually a lot more square. You shouldn't have so much perspective. So really I'd want to correct this image before doing this. However, you'll still get the idea. This image is then aligned to the point cloud. So in this case, it was aligned using these green dots you can see. And it's just laid on the back of the point cloud. That way, the image is now in scale because the point cloud is in scale. The point cloud is literally a series of measurements. It's what the laser scanner is doing. It's just taking millions of measurements. So when we bring data or start using the point cloud to create things, everything's in scale. If I start drawing over the top of the point cloud, or you know, measuring or drawing around rooms and things, it's all already scaled for me. So in this case, then I'm going to use this image and do some stringing for blood pattern analysis. Anybody who's done stringing knows it's hard work. It's difficult. Placing a pin on a blood droplet, physically drawing a string across the room, and doing it over and over again until you start to build up this picture. Now we do it digitally, and you can do it all pretty much automatically. So for example, I have this edge detection tool here. If I hover over a blood droplet, the software is going to highlight that blood droplet, point it in the right direction. If it does say find it in the wrong direction, you can just flip it. If you're really not happy with it, you can even zoom in and you can just edit it. You can just get these little sliders. You can just change it, make sure it fits really nicely. However, all the maths is done for you. Now, I always like to tell people to refer to this software as a calculator, or all of these tools as a calculator. This isn't to say that anybody can do blood pattern analysis. What I would recommend is your blood pattern analysis experts use something like this, and then they just double check all the maths, because all the maths is given to you afterwards. So for example, you can see my stringing building up here, and it kind of goes up this wall because it's from where a weapon's drawn backwards. So if I continue to do this, you'll just see this slow spread going up the wall. I could render videos from this, screenshots from this. But what is quite nice is I can do an instant report. So this report will automatically, you set it up and it will automatically have your details in, and you can customize these forms to have them however you want. Put your case number in and have your own logo there. And it will show basically everybody what you've done. So it will pick out the points you've used, and it will show you all the angles and all the maths. So again, this is where your expert can look at it and double check things. This software is always recommended to be like an animation tool and not a simulation. And likewise, it's where I'm coming from with the same sort of concept, that this is a tool for your experts. This is not to replace them in any way whatsoever. The expert always knows best. This is their calculator. So yeah, very quick then. That's an example of blood pattern analysis. You can still do it from a photograph. The really nice thing about this then is you can still just do it from a photograph and build your own scene without having a point cloud, but it has so much more context. It's so much better when you can place it into the laser scan, which is really nice. Similar then, another nice little tool in FARO Zone then is our bullet trajectory tools. Now, again, I would never say this is going to replace your ballistics experts. They are still very much needed. But what we can do is, on top of their ballistic rods that you've probably already got or seen, you can now place these spheres. They just slide on over the top. So you see these little blue, well, they're white spheres normally, but they've been marked as blue by the software. What we do then is we click on these spheres, and because we know the dimensions of them, or the software knows the exact dimensions of a sphere, it doesn't matter which angle you look at a sphere from, the center point is always the same. So if you mark the two spheres, you get two perfect center points for your rod. So now you have a digital ballistics rod as opposed to just a physical one. And this rod can be used to create a line, and you could extend it right across your scene. Even better then, because we're working from a point cloud, we can align the impact plane using the data, using the point cloud data. So that's what's just happened there. That impact plane is now aligned on top of the laser scan. So now I've got my ballistic rod and my impact plane. I've got all the measurements. The report is built for you, and it is that quick. What you just saw on the screen is how long it takes to build a trajectory report from a ballistic rod with spheres. And if you was to flick through that report, again, it will show you the angles of each and the mass with them all. So a really nice thing then is that's kind of customizable. So the cone itself, you can change the size of the cone for the caliber of the round, again, down to your ballistics expert. And you can extend these out really far. So then you can start seeing approximate angles or potential shooting locations. I had a really nice case, really. I was helping somebody in another country put one of these together, and I was going through the process with them. They'd done all the laser scanning, they'd already done all the crime scene, but they did assess the car, and they've used these spheres and these ballistic rods. From looking at the data in FARO Zone and looking at where one of these ballistic rods goes, it ended up looking like one of them, once you really extended the line out, it looked like one of them must have hit the floor and must have been a deflection, because it just didn't really add up with the other ones. And the crime scene investigator said to me, well, he's going to have to go back to the scene now to see if it's there. And he went back with an idea using the laser scan data and the whole report he had, and he went back a week or so later, and he found it, and he found the exact spot. But from using this data and using this method, it led him to where the bullet mark was on the floor, of where that deflection was. So he's now got more evidence. It was just really cool. And then he, took some really nice pictures of it and everything to build up his case. It's really nice. Okay. Again, I have to be conscious of time, but hopefully I can show you some of these capabilities. There is so much this software can do. Usually to show somebody everything, it would take me a whole day. The training, you know, there's a lot there because it's down to, you know, different people and what they want out of it, whether they're crash based or crime based. Not only that, fire, investigation, or security. However, this is like a quick example, and it is a bit fast. It jumps through a few different clips. This is some of the stuff you can do with crash because there is so much. So we're talking like virtual crime scene construction. You can place models back into the scenes, part and particle effects. You can build up on top of laser satellite imagery and do animation. This is an example of working from total station data. So if you've got existing, I just want to pause this part here actually. If you've got existing devices, it doesn't make them redundant. You could bring photography into this software and scale it. You can bring satellite imagery into it and it's already pre-scaled. Bring in total station data and use that along with your laser scan data. There's a lot. Or if you already have laser scan capabilities, there's a whole range of different formats you can bring in, along as 3D models, and you can do all the drawing in here. This is an example of different data being brought in here then. You can do a lot of different animation. Now, I did mention earlier, it's an animation tool and not a simulation tool. What I mean by this then is that you're required to put in the information as a specialist. The software can do a lot of amazing calculations for you, like to help you determine the critical speed of a road or the gradient of a road. It can do a lot of the maths for you. However, it will not simulate anything. Unlike something like PC crash, just because you put in a bunch of data, the software is not going to turn around and go, oh, I reckon this happened. We don't do any predicting here. Because anybody here who has used those type of products will hopefully vouch for me and say, you can manipulate them and you can make the outcome be what you want it to be, really. So this is not a simulation tool, it's an animation tool, and I can't stress that enough. There's an example of crush then, skid analysis. This is a bit more animation. Just a representation really of something that's happened. This is nice. You can add Google Terrain to your satellite imagery, and you know what? You could make a car drive up and down it. I've got momentum calculators, which are nice. There's a little bit more animation. I won't talk into just how the animation works. It looks a bit strange, but again, that's a whole nother session on its own. I know there's a lot going on here, but there's just so many crash tools. What I'll do is I'll load up the software. Hopefully I've got a bit more time. So what I'll do is I'll load up the software and just show you, give you an idea real quick. So let me start a new document. This is how easy it is to bring a point cloud in. So what I'm going to do is I'm going to import a point cloud. Mine's just changed. Hopefully I can find it real quick. Bear with me. I'll use this one. Okay, so the software is now recovering the data from our FARO Scene. And now I have this point cloud within FARO Zone. So this is where I can start doing analysis and looking at it really and checking different things. So again, because the point cloud is essentially just millions of measurements, it means all the hard work is done for us. So let me just make this a little bit clearer for you on your end. Just make it a little bit thicker. Now there's black and white laser scans in this point cloud and there's color ones, which is why it fades off in the distance up there. Very, very quick example then. We have these power tools at the top, and I could read the slope of this road as easy as that, as easy as clicking in two places. I clicked on one point on the road, clicked on the other point of the road. The software will do the calculation for me because it is just measurements and I'm just picking between two measurements. That simple. If you can learn to draw in this software, you can learn to use all of these power tools, which is great. So for example, if I was to draw a curve on the road, that approximately goes around the curve. That line drawing I just done snapped to the point cloud. So what I can then do is use my critical speed analysis and take that line drawing curve and now I have the critical speed of that turn. Sorry, I did do it on the left side of the road, being from the UK. But I think you get the idea. There's a lot of really fun, exciting things you can do with this software, just because all the hard work's done with the laser scan, all the calculations are done, all these measurements. You just then need to learn how to work on top of it and utilize it to, you know, show your investigation. So that is pretty much all from me. I think I'm just about on time. I'm fine if we have got some more time to answer any questions. I'll allow the others should be able to unmute as well.
Yeah, hello again from my side. Daniel, first of all, many thanks for this very interesting introduction of equipment FARO in the area of public safety and forensic. Really interesting. And I believe that we have also some question. Benjamin, can you help us here, please?
Yes, of course. The question it's in Slovene, so I hope I translated correctly. Daniel, can the system, I believe here we are talking about the scanner and the software, perform measurements of the objects, people, directly on the spot of the scene?
Yes.
And if we need to enter the reference to do it,
So no reference would be needed. I think I understand your question. Directly from the laser scans, you could move around your scene and you can measure any 2 points. You can pick out any of them and measure between the two. So anything that's been laser scanned, you can measure it. That is what the point cloud is built up of. When we saw it in the first software, every one of those little dots, that is a measurement. So that's a point, and you can measure between it. So yes, I hope that answers your question. Otherwise, you might be talking about geo-referencing the whole thing. If you're also talking about geo-referencing the entire scan, yes, you can also do that and then pick points.
Okay, for now we don't have any more questions. I suggest we wait a minute or two if there will be more. Andrei,
okay, yes. Anyway, if in the future will be some questions or perhaps some that we make additional detailed presentation for one of area of public safety or forensic, we can do it, of course. So anyway, these are our contacts. So please, if you have any question, just write us via this email or call us on these phone numbers. In the end, I would like to thank you to all because you are here on this webinar. Perhaps, Peter, also some final words from your side.
Yes, hello again. I really hope that we could meet all your expectations in this today's webinar, and that we could attract your interest on an ongoing contact with FARO, of course, based on our cooperation with IB-CADDY, our local partner in your region. Let me finally also invite you to visit our website, faro.com, where all our products and solutions are shown and underlined by practical case studies. And as already expressed by Andrei, let me underline that you please use really the possibility to place all your questions and requests to the email address, which will be sent out by our partner IB-CADDY after the webinar. Yes, we are definitely prepared to organize for you individual web sessions, web trainings, and also web demonstrations based on our professional web demo studios. I'm really looking forward to times in which we will have again the possibility to meet with you also on one of our live events in your region. And in the meantime, I say goodbye, see you soon, and stay safe and healthy.
Just a quick one. One last thing. There is a public safety virtual event coming up on the 9th of December, and it's 24 hours long. So there will be something there for everybody. If you want more information on that, just reach out. We'll make sure that a link goes out to that too as well, because there's a lot of really exciting speakers on there. So yeah, I think it's worth taking a look at.
Okay, great point from you, Daniel. Thanks for this. All our partners got also from our side invitations, also a draft to invite their clients and also their end customers. So I think it would be a good idea that you, Andre, also forward this invitation to all participants.
Yes, of course.
Today.
Of course.
So thanks for this point, Daniel.
No problem.
So thank you to all and see you next time. Bye-bye.
Thank you. Goodbye.
Ciao.